Dot product and work done means what is the usage of a dot product? Dot product and work done, cross product and area. So how these two are differentiable in terms of usage and example. If I have two vectors, this is a vector A and this is vector B, this is vector A and this is vector B. Okay, so there are two vectors A and B. Then cross product is the area between them. So if there are two vectors B and A, then whatever the parallelogram it makes, that is the cross product that we saw. And means cross product generates an area. And area has a direction. And so bigger the area is, cross product is bigger. So if there are two vectors, then cross product is 0 and cross product is growing and cross product is maximum when it is a rectangle, parallelogram to rectangle. Direction of the cross product, if this is the cross product net area, then perpendicular to the surface is the direction of cross product. So, usage of the cross product, like if this is the range, then if I apply range in the xy plane, then things comes out in z direction. Similarly, if I apply range in xy direction, then things work in z direction. So, the cross product usage is area in xy plane, but the resultant vector is in z plane. So, means perpendicular to the A and B. So, if A and B is like this, then the surface normal is the, so if it rotates, then everything rotates. If A and B are now here, then the resultant is perpendicular to the surface. So that is cross product. So cross product grows when the angle between two vectors grows up till 90 degree when it is parallelogram to it becomes a rectangle. Now we'll come to cross product. This is a mobile, okay, and this is force and this is object. Now, in line with the object, I am applying the force and mobile is moving, we can see. Okay, so this is object and if I am applying the force, then mobile is moving. So there is work done. So if there is a displacement of 1 meter and if I apply force 10 Newton, then 10 into 1. So that much joule is the, or a Newton meter, that much is the work done. Force into displacement is the work done. How much force I am applying, how much displacement it makes, if I multiply, then that is work done. If I talk about very conceptually how much it is moving, that is the work done. Okay, so if item is kept on y-axis, means x-axis, and if I apply force in the x-axis itself, then work done is happening on x-axis. Okay, now I am applying force from an angle. Earlier it was 0 angle. Now angle is growing. Now force is more to get same work done. Okay. Now it is easy to push. So if angle between the object, angle between the movement where the object is moving and the force are same, then it is easy to move. But as angle is growing, it is difficult to move it. Now, angle is 90 degree. Now I am pressing because force is going down. It is not moving at all. If I tilt little bit, probably 70 degree, 60 degree, it is very hard because I am pressing down and it is very hard, it will move. Okay, so whenever a scenario comes, whenever angle grows and things get less, it is dot product that comes into picture. If angle grows and things grows, then it is the cross product. Like I have a torch, okay, and if I try to glow this screwdriver, okay, how much it will glow? But if it has better area, and then if I try to glow it, it glows really nice. Can we see? So, I am using in parallel to the normal vector. Okay, it is really growing very nice. But okay, not much because area is less. So, as we grow the area, angle between the vectors and things grows, then it is cross product. But as we grow the angle and things lessen, decrease, it is dot product. Now, what is the work done? Work done is force into displacement. What is the force? Work done by displacement. If I want a particular amount of work to be done, then if I want particular amount of displacement to happen, then work by displacement is the force. Now, so force is equal to work done by displacement. So if it is aligned, if the force and displacement direction is aligned, then less force is applied to get the same displacement. So work done by displacement is force. So less force is required. If I incline the force with an angle to the same work done or displacement to happen, I have to apply more force. This proves that the force essence in the direction of the movement is important. Not what force I am applying, direction is important. So, if I apply force perpendicular to the movement, then force essence, that we say cos theta, that is the dot product. Here, dot product comes into the picture. The essence of the force is in y-axis, displacement is in x-axis, so 90 degree. So, the essence of the force force is in z direction. Essence of the force in horizontal direction is force cos theta. That is 0. Cos 90 is 0. But as angle is decreasing between the direction and the force, and if it becomes 0, cos theta is 1, cos 0 is 1. So work done is movement into force cos theta. So force dot movement is the work. How much force we are applying, it doesn't matter. What matters is the force essence in the direction of movement. That matters. So if force to get the same work done, to get the same displacement, if force and displacement are aligned, angle is 0. Force dot displacement, if angle is 0, is nothing but force into displacement. If force and displacement, there is angle theta, then work is force into displacement into cos theta. Force dot n, force dot the direction. So this is work done. Work done if I am applying. So in any, I believe people would map it to career and those areas also. How much I am studying or how much I am working. So it doesn't matter. If someone works 10 hours, 12 hours, 18 hours a day, it is not required that whatever the money is earning or how much, if I don't talk about the bad money, how much work is actually getting done, it is not necessary that what force we are applying, how much force we are applying, how much work we are doing. Whatever we want to achieve, I am not saying that if I am applying force from the top to top, then this is not getting the pressure. It is trying to push it down. But, so this is the mobile, if I press from top, it is pressing down. So it's not that nothing is happening, but it won't move in this direction. Means this is not what I want. I would get paid or I would get satisfied because I need to move in this direction. Or like a railway coolie is pulling or pushing something. Work done is only possible when things would move 10 meters, not things would go down. Okay, so the end result is the expectation is that luggage should move horizontally. So if I apply force vertically, luggage would not move at all. So how much force we apply to get our work done is important, but main thing important is what do we want to achieve. Force should be applied with a zero angle. So there should be in a kind of in synergy. So if force is in synergy with the displacement required, then it is the maximum work that we get. Force cos theta into displacement direction is the work done. Force into displacement, if I say it n, F dot n is the work. Because if angle grows, work is getting less. Whereas if angle between two vectors grows, then light grows. If I throw the light on an object, so if angle grows, that is cross product. So cross product increases when angle increases because it is sine theta. Dot product decreases when angle between two vectors angle between two vectors increases. Dot product decreases. So work done in the sense of dot product is milestone to understand the dot product. Whereas the lighting model, what we saw, is a milestone when we think about the cross product. In cross product also we saw the dot product, like if I place the light here, this is the light source and this is the area. If I place light along the normal of the cross product normal is in this direction. And if I put the light exactly in the normal direction, then here also, then the light illumination is maximum. So the dot product of the normal, dot product of the cross of the two vectors direction and light source, if they are aligned to each other, so angle between them is zero, then specular and shining component is maximum. But if the light is changing the direction from the normal direction, angle is growing and it is coming vertical to the normal, then there is no light falling on this surface. So dot product decreases with the angle between the vectors, whereas cross product increases with the angle between the vectors. So work done dot product.